hope you've enjoyed the program so far today, touring our very new exhibition called Rivers of Ice, the Vanishing Glaciers of the Himalayas, with our expert tour guides, many of whom have seen the exhibition for the first time with you. So I'm guessing that you enjoyed your tour and impression of the exhibit with your tour guide. But right now we have a little bit of time for each of the guides, who will now become panelists, to speak very briefly about their impression of the exhibit, personally, scientific. They'll give you an idea of what they saw and will then give you a chance to ask questions of them. Our moderator this evening is going to be Dr. Kurt Sternloff, who is director of MIT's Earth Systems Initiative, and he will take us through this fun and fast-paced discussion.
And Brenda, how long do we have?
Well, each speaker has 3 minutes.
Oh, okay. So again, welcome everybody. My name is Kurt Sternloff, as Brenda mentioned. And what I wanted to do is, she's already mentioned that I'm the executive director of the Earth System Initiative at MIT. So the Earth System Initiative is a research group at MIT that's focused on understanding the Earth as a unified system. And by Earth, I mean actually, the envelope of the Earth in which we live, the biosphere. And what I wanted to do to start off with actually is to just ask each of the panelists now to briefly introduce themselves as well. And then we'll go back and I'll just give a few of my personal impressions of the exhibit, go down the line, and then open it up for a discussion. So, John?
Okay, I'm John Durant. I'm the director of the MIT Museum.
My name is Patrick Heimbach. I'm a principal research scientist here in the Department for Earth, Atmospheric and Planetary Science, and I study the oceans. I'm a physical oceanographer. And, okay.
Go ahead.
Well, you might be surprised, why do physical oceanography is interested in glaciers? Well, I have one as a very personal interest because I'm a mountaineer and climber. I love climbing, so these are spectacular landscapes to see. But also, as physical oceanographers, we're trying to solve the sea level puzzle. We see sea level is rising, it's been for the last 2 decades. We see this from satellite data at a rate of global mean 3 millimeter per year, and we try to actually understand where do these come from, to what extent is it warming and thermal expansion of the water masses, and to what extent is it runoff from for example, the polar ice sheet, Greenland and Antarctica, but also all the other glaciers that are not in Greenland and Antarctica. And evidence at the moment seems to suggest that all the non-Greenland and Antarctica glaciers provide as much runoff and contribution to sea level rise as do Greenland and Antarctica combined. These numbers are still uncertain, and so the research on this is actually rather fascinating. But this is how oceanographers get connected to even what's going on in high mountain glaciers.
I have laryngitis. I'm Laura Knott. I am the exhibitions coordinator for the MIT Museum. And this was not the first time I saw this exhibition. I've been working on it for the last 1.5 years.
My name's Alistair Doyle. I'm a Knight Science Journalism Fellow. I normally work at Reuters as the environment correspondent, so I'm interested in learning about the glaciers of the Himalayas, which is also the first time I've seen them this afternoon. Thanks for those who stuck around with me on the tour.
I'm Susan Murcott. I'm in the Civil and Environmental Engineering Department at MIT, and my work is in water and sanitation infrastructure in developing countries. I work with the bottom billion, the billion people who lack access to safe water and sanitation. I also have been a mountaineer and avid hiker, and have had the privilege of seeing Everest and of hiking Annapurna and other Himalayan peaks. I actually wore my Tibetan vest today because I have worked in Nepal for 7 years with teams of students. I also brought some notes and a slide. I'm not sure when I get to show the one slide that I was allowed, but I wanted to say a few words. That the exhibit shows in the opening map the watersheds that the Himalayas feed, and we learned that there's about 1 billion people that are dependent on those watersheds. So that what we saw only a little of in the exhibit is the people who are impacted by the melting of the glaciers. We certainly saw the drop in the vertical heights as we compared certain pictures, but I wanted to speak for the glacial dependent societies who are vulnerable to water scarcity due to the drying up of glaciers. Climate change is not the only factor causing the depletion of water resources. Increasing demand is also a factor, and that's caused by other pressures as well, like population pressures and development pressures, by essentially unsustainable development. We've studied two local governments in Himalaya communities, and what we found was that most of those two governments were taking steps to increase the supply, but that they weren't taking a more holistic approach to addressing climate change in their communities, and that they were typically lacking in planning and policy skills in knowing how or taking steps to address loss of water resources. And so the last comment I wanted to make is that there are adaptive methods and technologies that are in their early stages to increase reservoir capacity, to increase leak detection, to adopt appropriate sanitation measures, to enhance monitoring and reporting, and for example, sustainable tourism can help this region to integrate its changes with an economic sort of opportunities. So I think I said more than 3 minutes, but thank you.
That's all right, because I won't take close to 3 minutes. I'm Judy Laser. I'm a political scientist. I'm in the Department of Urban Studies and Planning at MIT. And I would like you all to guess, wow, this is an amazing crowd. It's really impressive. I would like you all to guess why I am here and why I would be at an exhibit of melting glaciers in the Himalayas, because I study politics, I study environmental politics, and I focus on the United States. So it's up to you to figure out why.
You are available.
There you go. And if you can't figure
What do I
out
win?
why I would be here, then we're in even bigger trouble. That's all.
So we've all introduced ourselves, some a little longer than others, but I just wanted to still go back and give an opportunity to give a few impressions. But my intent was, and I'll start, just both personally and professionally. It's the first time I've ever seen the exhibit. I mentioned to the group I was with that I just was walking through with them and just talking out loud the things that I would have been thinking to myself. And I'm a structural geologist, so I'm fairly well acquainted with what's going on in terms of the Himalaya actually rising. What's the tectonic drivers of that? I tend to think in geologic timescales of millions of years. And what strikes me when I go and look at these photographs, well, the first thing that strikes me is how much I love the black and white photographs. They're just incredible. And there's something special about those. And I've worked with some of those large format cameras myself, and I just have a lot of respect for how those photos were taken. But when you look at that, basically what I think of is, it says to me how changeable the biosphere is, how changeable our Earth is, the world in which we live. And you can see that, as was mentioned in terms of the changing levels of ice. You think about that in terms of what it means for the river flows coming off of the glaciers, whether those are sustainable, regardless of whether that's actually driven by us, part of a natural cycle of ebb and flow in the glaciers, or I would say a combination of the two. The fact is that we live on a changing planet, and it makes me think of the degree to which we need to be aware of and adaptable to that. So, who else would like to fill in a few thoughts?
I've only been doing museum work for about 7 years. Can you hear me at all? Okay. And I have to say that I see exhibitions completely differently from how I did before I started working on them. I now sometimes alarm guards in museums by sticking my head against the wall to find out how something is hung, for instance. But the things that have really kind of surprised me after all this time working on this is how effective the physical experience of two things have been. One of them is the panorama. standing in that 360 degrees as a physical experience of being surrounded by those images, I think is really very powerful for me personally, and I was delighted to see it go up, and I also think it has very cool acoustics. And the other thing is, those, I don't know how many of you saw those boots with the nails in the bottom of them. We borrowed those boots from a museum in Canada. They just arrived about 2 weeks ago, and I had heard about hobnail boots because, like many of you, I'm a Beatles fan. And it was, there they are. There are nails in the boots. So just the remarkable physical difficulty and arduousness of traveling to these places and taking those photos and bringing them back for reasons of acquisition of knowledge, and then in this case for sharing them with the public, I think is just really remarkable.
Yeah, but I think the exhibit is fantastic. I mean, as a climate journalist, I quite often see reports about the melting of glaciers related to climate change, but there you only see pictures in a tiny little format, and this, that somebody managed to track down exactly the same spot where somebody had been in 1920 or 1909, I think that is fantastic bravery, if nothing else, and what a lot of research and waiting for the right weather. Sometimes the clouds are almost exactly the same as they were in those pictures from those times. But I mean, I think I'm a bit on the same wavelength as Judy here, in that there has been a problem with the melt of the Himalayan glaciers, in that the UN panel of climate scientists said, made a mistake in their 3,000-page report, 2007, that said that they could all melt by the year 2035. Now, of course, you know, as we looked at those pictures, I think it's clear that they are receding, but it doesn't look like they're all going to be gone by 2035, and that indeed was a mistake, which was later corrected. It might have been a typo from the original number, which is the year 2350 is one explanation, but either way it was wrong, and it's been latched onto by all sorts of people as discrediting the panel, which is a bit hard to push when, you know, in a report of 3,000 pages there are two relatively small mistakes like that which didn't make it through to the summary for policymakers. Although I think that it did, you know, that mistake did highlight the extent to which the UN, the IPCC, the Intergovernmental Panel on Climate Change, relies upon grey literature, which is a bit dodgy in that it's not peer-reviewed science. This report that they were relying on here was filtered through the WWF, quoting somebody else, and that's not a great way to produce the world's sort of Bible of climate science.
So just a couple of observations about the exhibition, which are not about the technical issues that the exhibition raises, because I'm not technically expert in any of those. But because I work with Laura and others in the museum, a couple of things strike me about this exhibition. The first thing is it was quite crowded up there today, but we've only just seen it coming through in the last few days, and it is actually really very beautiful. And the images are just stunning, and the way they've been arranged in the space, I think you'll agree, is quite extraordinary, and that's due to a whole group of people, obviously to the original photographers of the historic images, who we can't thank personally, to David Brashears and his team, who we can and have done, but also to the exhibition designers, who are called Think Design. I don't think our colleagues from that company are here now. Are any of our friends from Think Design here? Hello.
There's Sherry.
There's Sherry. Well, we really do owe a lot to them for having come up with such a brilliant, it's quite austere, quite laid back, but quite beautiful, and it lets these images sing off the walls. And I'm very grateful to all of those folks. But the fact that Laura is having trouble being heard is also a way for reminding me that a lot of people, Laura not least, worked very, very hard to get this to happen. And Laura hasn't just lost her voice in this, she's lost an awful lot of discretionary free time over the last 6 or 9 months. So I'm very grateful to the whole team for making this possible. I do think one of the messages of the exhibition is, and in fact it's stated in there in a quote from the eminent French natural philosopher Poincaré, that scientists, for example, and explorers, for example, don't only and solely go and find out what they want to know because it's useful. They go and do this because it's fascinating and what they produce is beautiful. And I do think this area of exploration and research is a case in point.
Maybe I just want to make one small addition to that statement. Oftentimes it's said that, these pictures, that we look at the pictures, and in terms of the science, there's not much we can get out of them because they are not hard numbers. But I would counter that really the imagination that these pictures give us. I mean, we are stunned by them. We would like to understand what we see, and this brings young generation to say, well, I'd like to study this in more detail. This in itself is just an incredible value. And even for us scientists, sometimes looking at the picture, at the ground truths, instead of sitting in front of our computer simulations, just gives us a lot of inspiration to look in more detail at what we need to look at.
Yeah.
All right, so now, we've, not surprisingly gone on probably a little longer than we meant to, but I really want to make sure we took a bit of time to open it up to you guys and see, any thoughts, questions that you might want to ask, and in particular, if anybody wants to answer Judy's question.
Why is she here?
Why is she here?
Everyone really wants to know that.
But please, we'd love to hear from you.
So shall I ask you? I'll just hand it back to you.
Just yell into it.
I would like to understand the role of the Himalaya glaciers in sort of regional and world weather patterns. I encountered the melting glaciers in airplanes flying out of Delhi, leaving around midnight, off and on for the last 2 decades, where the ground mists would be so thick in the northern plains of India, and the radar so bad in the Delhi airport that the planes couldn't take off, and they'd be postponed for a day or two. That was just the tip of the iceberg, so to speak. I learned later that the glacier, what's happening with the glaciers and the snow covers, has an effect on El Nino and that whole weather pattern, and it has an effect on monsoon intensity and direction as well. But I can't say I understand it, and I was wondering if anybody here can explain it, because if it does affect El Nino, then that could be one reason you're here.
That's not the answer.
I mean, I can try at least some of this. The main weather systems that we have in what glaciologists call sort of the high mountainous Asia, so that includes Himalayas, the Karakoram. So of course, the dominant driver here is the monsoon, the summer monsoon, as a result of the temperature difference in the summer between the ocean and the land, has these very strong and very moist air masses that move into the continent. It's triggered by the elevation by the presence actually of the Himalayas, and so you have this very moist air and bringing lots of rain in this area. This dominates the Himalayan range. If you go further north and northwest, those mountains, the Karakoram, are actually more dominated by the similar thing that we see here, which is the jet stream. And so the precipitation patterns are going to be different in the north, where you have a lot of winter precipitation governed by the jet stream, as opposed to the Himalayan range that's dominated by sort of the summer monsoon. And then, of course, as you saw in those pictures, you have these very interesting topographic effects of deserts behind these high mountains, where like the Taklamakan Desert, just a high dry desert, or the part of the Tibetan Plateau. So really fascinating in terms of climate, looking at climate variability. Connections to El Nino, I think it's a bit too long to go into here. So I'm not going to go into speculating this, but I think really these dominating this sort of the regional effect, that also has repercussions on the local water supply of the different river basins, like the Indus River that goes to the west, and then the eastern rivers like the Yangtze River and the Ganges River.
Are there any other questions for the panelists?
The melting of the glaciers, I'd always assumed that they just sort of melt down sort of uniformly, but there were some very dramatic pictures up there of sort of pyramids forming, pyramids melting not uniformly, but there was a picture of, I don't know, David Brashears or somebody rather on one, and it sounds like something, some interesting physics are at work there. Anybody have any idea what that is?
This is why we have Patrick for the ice science. This is cryospheric science, or the frozen world. So, Patrick, take it away.
Well, this is once the glacier has almost melted to the extent that you have a lot of sublimation of sort of the little remains. What I was going to point out, sort of one interesting aspect is sort of glacier has a lot of intrinsic variability, and surging glaciers is those time scales are long, but glaciers can episodically start to flow very fast on the order of a few kilometers a year. They will do that. They will set on and they will maybe surge for, let's say, couple, like 3-4 years, and then they will come to a rest, and then they will not do anything for many decades. So these phenomena, and trying to understand, this is a phenomenon observed more in the northwestern part of the glacier, where the temperature regime at the base of the glacier might play an important role while you see this surging effect. And it's almost like if you could look at this in sort of time lapse and much for sort of speed up, it almost look like a caterpillar movement where you have this fast forward movement and then slowly the glacier retreats again. So glaciers are dynamically very active system, lots of things going on within them. And so sort of thinking that they're just sort of this peanut butter that just slowly spreads down and that's it, is sort of too simple of a picture. And that also has repercussion on how we interpret glacier change, because glaciers might not change everywhere and just melt everywhere, and there will be regions where they will actually increase, and they are currently increasing. This is not a counter-argument, say, well, see, climate change isn't happening. It just means that the local regimes in these regions are very different because the precipitation has increased.
Anyone else?
Somebody at the back. Hold on.
All right. Well, my name is Alex, and I'm one of the organizers of Transition Framingham. I wanted to answer the question, why do we have somebody here about policy? Because you haven't talked too much about the science of climate change and like, ooh, look at these melted glaciers. I wonder who could have melted them. And I think we know the answer, but we haven't said it, or at least some of us know the answer, but haven't said it. So I'll go ahead and say it. It's been humans. Thank you. Thank you for the applause. And then the next question to a living, breathing, red-blooded human is what to do about it, right? So you might start biking to work instead of driving. You might, like, recycle. I don't know how that's going to save the planet. You might think that because government policy certainly affects our carbon emissions, you might think that would help. So that's why we have a policy person. And you might think that if we act on the scale of communities, we also might be able to change our carbon emission footprint in how we live. And that's where the Transition Town movement comes from.
So let's go to Judy now, live to Judy, and give her an opportunity to speak to that.
Well, again, I think probably your perspectives on this in some ways, all of you are more helpful than mine, but that's exactly right. I think the second piece of it was why, not just policy, but I studied politics, and I studied politics in the United States. So you were hinting at that, but I think what you also have to say is it's not just humans, it's particular humans, right? It's American humans. We are responsible for the vast majority, right, of this problem. And we are also the ones who are most resistant to doing anything about it. So there are plenty of culpable people in the rest of the developed world, but they are also much more game to address the problem. So we are the holding problem here. And I guess I'm wondering what other people think we need to do about this. I spent a lot of time thinking about why that's so and what we can do. I certainly think acting in communities right now is the only place we are acting. We're certainly not acting in Washington, right? So, but it's not really my way to so much belabor this as to try to elicit responses or thoughts from those of you who are actually the people who could make a difference.
Thank you. I'm sorry, I didn't catch your name, but the Knight Fellow journalist.
Alistair.
Alistair, good. You brought up the very interesting point about the Himalayan glacier typo mishap in the IPCC, and of course in the media that was what was latched onto, and the more important picture of, well, the pictures that we have upstairs of the glaciers melting and the impacts and how that ties into the bigger picture is not as simple and easy to understand as the mishap, so that was not so much covered in the media. So my question is basically, as a journalist, what has been your philosophy about communicating climate change science? And do you have an idea of how we can better get across kind of the basic, non-controversial part of climate science to the public?
Yeah, that's very difficult. Actually, I noticed that this slide came up. This is a picture that I took in. It's completely irrelevant to the Himalayas, but this is the Wilkins ice shelf in Antarctica in 2009. I was with the British Antarctic Survey when we landed on that ice shelf. 3 months later, it collapsed. It's not there any longer. This is part of the world that has ceased to exist in the sense that it's not ice any longer. It's open sea. So it's that sort of story really, I think, was one of the ones that took off in the media around the world, at least an event like that. The problem with climate change, I think, for getting it across is how slow it is. You know, you can look at the pictures upstairs and, wow, you can see that the glaciers have receded since 1921. But, you know, you go back next year and maybe there will be a bit longer, a little bit shorter, but it's the slow pace of it, isn't it, that to try to get across to people. The way I cover it, I don't have a sort of he said, she said. Some people say that global warming is happening. Rick Santorum says it's a hoax, or that sort of dialogue. And especially in Europe, we don't. I think most media have moved on. That most media have accepted it. So I tend to take the IPCC. The conclusions were after all approved by 130 governments, including the United States. So why not sort of I just quote what the IPCC says generally, and then say they've got into trouble with a few of their things, but generally their conclusions are solid. But telling the story, it's very difficult to tell the story in a way that will reach out to people who don't like those conclusions. I think that's the challenge. You've got to find, I mean, as some people say, you've got to find a Texas windmill owner who can say, hey, great, I'm making money out of windmills, wind turbines now. And it's not really so much about climate change, it's a solution. To look beyond the science perhaps and try and find examples where people are benefiting from policies of changing climate, of reacting to it. I've been covering the climate talks for a while, and I can remember the UN talks when Barack Obama's first, Todd Stearns, his representative, turned up in Bonn in April, perhaps 2009, I suppose, and he had to say to people, I do not have a magic wand. He made a point of it. He says, I'm not arriving here like the cavalry to solve this problem, and certainly he wasn't. But he was applauded in his first speech, interrupted by applause 2 or 3 times, because the other governments, or many of the others, hoped that this was a turning point in the debate. It hasn't been, so let's see.
I understand that some of the human-caused climate change has been from industrialization, but I also wonder if anyone has teased out from the numbers what the spread throughout the world of air conditioning has done.
Any number of us could probably sit up here and conjecture a little bit about that. I would say that we probably can't speak to that, other than, you think of the air conditioners, certainly they're being run on electricity. The electricity is being produced probably by burning fossil fuels, and so it's having an impact, at least in that regard. I don't know if you meant something else by that. The air conditioners themselves, I mean, the laws of thermodynamics of demand, basically waste heat is being created. So
the technical question I don't want to try to answer, but I will say that there are folks, architects at MIT, who are thinking about this problem in terms of why would we build the same building in the tropics that we would build in Manhattan? That doesn't make sense. And they are thinking about trying to design buildings that have actual airflow, so you don't need that kind of air conditioning, that are different heights, that are thinner, or have green walls, any of the millions of things you can do in the tropics to avoid using air conditioning more than necessary. Of course, once again, most of these tropical countries, their energy consumption isn't even close to ours. So, sure, okay, the American hot areas, but my understanding, and I bet someone in this audience knows better than I, but heating is actually more energy intensive than cooling. So in fact, although air conditioning is a scourge and we don't build well, we also here in the Northeast, normal winters actually use heat, and that uses a lot more energy. Yeah.
I have a pair of questions related to the rivers that come out of the glaciers, because I think the woman here said that 1 billion people live in the watershed of the Himalayan glaciers. And one is whether anybody knows whether the melting in the glaciers over the last century has changed the water flow in the rivers. And then my other question is whether in the flow of the rivers, whether most of that comes from monsoon rain, so it's sort of supplied annually, or does a great deal of it come from the glaciers through normal melt that happens every year?
You want to give it a shot?
I can give it a shot. I mean, I'm an oceanographer, but there are very recent studies, for example, last year in the proceeding of the national academies, where people are really trying to quantify those effects. And the result is, again, it's not even. You go in places, again, in the Himalaya, in sort of where it's sort of more monsoon dominated, a lot of the water supply, the further you go away from the glacier, the terminus, into the lower valleys, the more it's mainly fed by the monsoon. So maybe up to 5 to 10% is still glacier water. But now, if you go again, sort of the rivers like the Indus being fed by the Karakoram, those numbers are potentially much higher. They can go up to 30%, and those numbers are very fragile. This is very new research. Really, people are trying to understand this in more detail. You have to use model because it's very difficult to tease apart. The main conclusion is in certain regions, perhaps the glacier melt is not that important. In other regions, more to the west, it might be quite substantial. And then also, still we think about the big 1 billion sort of people, but think about the local communities. Actually, the more you go in the vicinity of where the glacier ends at higher altitudes, there clearly most of the water supply is coming from the glaciers. And it's still those communities, although they are not the 1 billions, that are still being affected by this.
I have one little thing to add to that. Like I said, David Brashears just got back from Everest Base Camp. He's leaving in another few days, and one of the projects he's going to be working on is a project for the University of Colorado called Follow the Isotope, where he's going to be taking samples from glaciers at different levels, from spring water and from streams, to find out for 2 tributaries where the water is coming from that feeds those tributaries. So it's ongoing research, and some of the climbers in the area are beginning to contribute to it on the ground as well.
Just a very brief addition to that, because these comments do make one thing clear, which we have learnt in the museum really, really loud and clear, which is that this is an area of active research. Many of the questions I suspect that are being asked from the floor don't actually yet have general satisfactory or complete answers. We've become so conscious of that one thing we've done on the website for the exhibition and up on a screen in the exhibition, we have a feed which allows us to post relevant new results as they come through. So this is just a way of saying if you follow this exhibition, for example, on the web through the MIT Museum website, you should be able to get at least some sense of where the new data is coming from on some of these sorts of questions. There's active research going on now. David this morning was talking about a multi-million-dollar study precisely on this question of just what the different components of the river water in different parts of the Himalaya actually are, which implies that we don't really know quite yet.
How long is the website going to be up?
We're planning to keep that up for the whole year. This exhibition stays open for virtually a year until March next year, and we will keep that website current with at least our best shot at a sense of where the new research is informing the debate.
So, Britta, we have one last again.
This is a geopolitical question. You talked about the Himalayas, part of it goes through China. China, being now the large growing economy, right? It's burning more fossil fuels, coal than we are now. Do any of you know anything about how this is impacting China? Is it being talked about there? And how you see that impacting that long term? Because they're the gorilla in the room that's going to really have to be addressed, even now as much as the U.S., if not even more.
I was just going to make one very small point, and that is that I've been to the Taklamakan Desert, which is the desert in northwestern China. The temperature changes there are quite dramatic. It is said to be one of the hottest places on Earth, and the time when I was there was 120 degrees. And that was daytime temperature. So I know that there are climate impacts in that desert region, but I can't give more specifics.
I think, yes, they are aware of this in China, and they are concerned about it, and in many ways, they're doing more than we are. They're moving faster on efficiency standards. They're moving faster in alternative energy. They're also building more coal-fired power plants than we are right now. Nevertheless, we continue to be, many times the impact per capita. And the problem here, I think, is that it's difficult to ask China not to develop when we're not willing to give up anything ourselves. And that doesn't make a very good political story when you're trying to negotiate with the Chinese. So there's no question they are now the world's largest emitter as a country, but when you turn it to per capita, we're still looking pretty much like the source of the problem, and yet we aren't willing to set an example for the rest of the world.
Sorry, since we had just talked about geopolitics, I did want to point out sort of on a small scale a human tragedy that's still unfolding, and that's the war between India and Pakistan that's been carried out actually in the high altitudes of the Karakoram. So the prominent battleground there is the Siachen Glacier, one of the largest glaciers outside of away from the polar ice sheets. We just had, this week, we had news of 130 soldiers perished in an avalanche. And this is basically part of an ongoing war for several decades now, where millions of dollars are spent per day for maintaining troop levels at more than 20,000. And where, by some estimated numbers, about 5,000 soldiers have died there over the last 20 years, most of them not in direct combat, but actually just in environmental hazards, avalanches, and so on. So there's actually been a piece in Outside Magazine in about 2003, unfortunately I forgot the author, a lengthy discussion about this. And in the science community, we thought, gosh, wouldn't it be nice if we could turn this into sort of that money into research on what's going on these glaciers as opposed to having this war going on. So I had to mention this because geopolitics was mentioned here.
All right, well, so we're going to wrap this up right now, and I guess, I get the opportunity to have one little last word here, and what I want to do is just drop back a bit from my sort of geologist perspective, step away from some of the details, and just mention again, when I opened up, I talked about how changeable and changing and evolving the Earth as we know it is. And I just want to say that, it would be wrong to say that humanity is solely and purely responsible for the retreat of the glaciers that we see upstairs, that we're purely and solely responsible for climate change. I would say we're a very large exacerbating effect, but these things also happen on their own and have happened through time. And the reason I point that out is more that, I want to make the point that it is a changing world, and you shouldn't leave this with the thought that if we did everything exactly correctly, that we would be living in a constant Garden of Eden, or that the Earth would stay the way it is. That is not true. The planet is evolving, it's changing, the glaciers ebb and flow. We have an impact on that, and we are impacted by it. And learning how to live on Earth in a sustainable way, understanding that sustainability doesn't mean that the Earth isn't going to change anyway. That's really our goal, I think. Now, I wanted to also just say, I'm going to go back up and look at the exhibit again, because I didn't get to see the whole thing. There were too many people up there. But I would invite you all, I'd love it, I think if you could all come back up and let's go through the exhibit again with our eyes slightly opened by the conversation we just had. And thank you all for coming.
Thank you.